It's Kevin from Coding Pals here, and today we're going to be looking at the 2016 CCC'16 hidden palindrome. So a palindrome is a word which is the same when read forwards as it is when read backwards. For example, mom and Anna are two palindromes. A word which has just one letter, such as A, is also a palindrome. Given a word, what is the longest palindrome that is contained in the word? That is, what is the longest palindrome that we can obtain if we are allowed to delete characters from the beginning and slash or the end of the string? And for the input specification, it says that the input will consist of one line containing a sequence of at least 1 and at most 40 lowercase letters. And the output specification states that the output of the total number of letters of the longest palindrome contained in the input word. So if we just look at the sample input of banana, it gives us 5 because the longest palindrome in that word is anana, which has 5 letters. So to do this, we first have to take in the input. So we have n equals input. Next, we need a counter for the longest palindrome in that word, and we will make that d. So first we set the counter to be 0. Then we need to run through all of the different combinations of letters, and to do that, we first off start with 2 for loops. So we first use for I in range, 0, length, n. And the reason we're using length n plus 1 is because we're using splicing in this case and not indexing. So we have to use the length n plus 1 because otherwise it's gonna cut off. So first we set this variable p to be equals to n, the index between I and s. So basically how this code is going to work is that p is going to run through all the values. Like let's just take banana for example. The first time it runs, the I and s will both be 0, so we won't get anything. But the second time it runs, it'll be 0 and 1, so we'll get b. And then it'll be 0 and 2, 0 and 3, 0 and 4, and then on and on. Then it'll be 1 and 0, which won't give us anything, and then 1 and 1 also won't give us anything. And then 1 and 2, 1 and 3, 1 and 4, and on. And then it'll do that the same with 2 and 0, 2 and 1, 2 and 2, 2 and 3, 2 and 4. And then that's basically how we're going to test through all the different combinations of letters. So now we want to see if this p is a palindrome or not. So if p equals to p double colon -1. So basically this is just a function you can do. What it basically does is it reverses p. So if let's say p is ABCD, what this would do is it would reverse it to DCBA. And now if these two are the same, then it's a palindrome. So we'll set this new variable g to be equal to the length of that palindrome. And then if our g is larger than the d, since d is supposed to be the current largest length of a palindrome in our word, then we set the length g to be the new largest length of the palindrome in our word. And then at the end, all we have to do is print d. So now let's test our code. And yeah, as you can see, we done it.